Hey everyone and welcome. I'm Shraddha Patil and today we are diving into one of the most practical and important concept in machine learning, that is transfer learning. Transfer learning is the idea that you don't have to start from the zero every time. You build an AI model, think of it like a student who learns to read in a one class and then uses that reading skill to master history, science in also other subjects. This this core skill is transferred. This saves a huge amount of time and the reason many modern AI applications are even possible. Let's look at the formal definition. Here is the formal definition. Transfer learning is a machine learning technique where a model that has been pre-trained on a large and general task is simply adapted to a new related task. We don't train model from the scratch, we just reuse it. Think of it like this: the model has already spent significant time and resources learning vulnerable patterns and features from the initial large datasets. Now, instead of starting from the zero, for your new problem, you leverage that pre existing knowledge. This allows you to tackle the new problem much faster and with significantly less time. This is powerful. A classic example is using a model trained on general images like ImageNet, reusing it for a specialized task such as medical image classification. So why we go through this process? Because traditionally model training is really challenging. Training a model from the scratch need a huge amount of data, significant time, and lots of computing power. Transfer learning mitigates these challenges by reducing need of large data set, decreasing training time and cost, boosting performance in a low resource environment, enabling rapid experiments and prototyping. This takeaways is simple. Training from scratch is data hungry, slow, and compute intensive. Transfer learning is fast, gives a better accuracy, and works well even with limited data. How does this actually work inside the neural network? Transfer learning involves a structural process. We start with the pre-trained model, which is original architecture with learned weights. We use a part of this as a base model. These initial layers of a deep learning model often learn general features like age, texture. We treat this as a transfer layers, essentially freezing their learned weights to train the fundamental knowledge. Then we remove the original output layer and add new layer for our specific task. The final step is fine tuning, where we train the new layers and sometimes slightly adjust the weights of a frozen layer using our smaller dataset of for targeted task. This is how the transfer learning works. This visual perfectly illustrate the difference between training from the scratch requires a huge data set to learn all the features from the zero. But in transfer learning, takes a pre-trained the CNN, like one train on vehicles, and then just fine tunes the weight that much smaller set of a new data to successfully classify the car or a truck. It drastically saves the time and improves the accuracy. So, transfer learning is not a single technique, it has a several core types, mainly classified based on whether the data is labeled and how different the source and the target tasks are. We have mainly four types: inductive transfer learning, which uses different tasks with labeled target data. Domain adaptation involves using the same task but adapting the model to a different domain of data, still with labeled target data. Unsupervised transfer learning focuses on different tasks without any labeled target data. And transductive transfer learning deals with the same task but works with the unlabeled target data. This variety allows us to apply the concept of uh, transfer learning in almost the any scenario. So let's look at the ultimate comparison, traditional learning and transfer learning. What is difference? Traditional learning starts from scratch. It needs a lot of data, time and computation. In contrast, transfer learning uses a pre-trained model to train for the training, yeah, and also it is faster and works even with a small data set. For example, suppose instead of training a CNN from zero, we can just fine tune a models like ResNet or MobileNet for the medical image classification or the analysis. Let's look at where this is being used. Transfer learning is crucial in many areas, especially in computer vision. Key application include image classification, such as identifying what's in the picture. Next is object detection, which involves locating multiple objects in an image. Next is semantic segmentation, where every image pixel is an image is classified. And finally, the style transfer, which is used to apply the artistic style of one image onto the content of another. This application demonstrates the immense power of versatility of reusing the pre-trained the models. So transfer learning is not just a efficiency trick, it's a paradigm shift in how we approach the deep learning, making a complex model development accessible, faster, and more resource friendly. So that's it. Thank you for your time and attention.